Welcome to the art and science of outlier detection. This video is a master guide to identifying, visualizing, and managing statistical anomalies using the Interquartile Range, or IQR method. An outlier is a data point that differs significantly from others in a dataset. These statistical anomalies are primarily driven by measurement errors, natural variability, and exceptional events. Outlier detection is crucial for analytical integrity. It drives data cleaning, ensuring statistical accuracy, supporting anomaly detection, and verifying findings in scientific research. The 1.5 times IQR rule is the standard for robust detection, balancing the need to flag genuine outliers without overflagging. It is highly robust, intuitive, and allows for adjustable sensitivity. The first step in using the IQR method is deconstructing your dataset into quartiles. These four equal parts, Q1, Q2 the median, and Q3, allow us to analyze dispersion. The outlier detection workflow involves 5 steps: sorting the data, calculating Q1, calculating Q3, computing the IQR, and finally, defining the boundaries to identify outliers. Outliers are commonly visualized using a box plot. The box represents the IQR, the median line is Q2, the whiskers cover valid values, and the points outside the whiskers are the mathematically confirmed outliers. The MiniWebtool calculator helps automate this process. You input the data. The tool calculates the results using the 1.5 times IQR rule and then provides a summary and visual box plot. Interpreting outlier frequency is vital. 0% suggests a homogeneous dataset. Less than 5% is normal, but warrants investigation. More than 10% signals structural issues in the data. Use the action matrix to decide whether to remove or keep anomalies. Remove them if they are errors or invalid values. Keep them if they are genuine observations or critical to the research question. If data removal compromises your study, consider alternative approaches. These include data transformation, employing robust statistics, Windsorization, or conducting a separate analysis with and without the outliers. Anomaly detection has cross-industry applications. It is used in quality control, financial analysis, scientific research, healthcare, and sports analytics to flag unusual and critical patterns. The IQR approach is robust but has limits. It is unreliable for small sample sizes, non-symmetric distributions, multimodal distributions, and temporal data, which require specialized methods. Maintain statistical integrity by following these expert guidelines. Maintain a sufficient sample volume. Apply domain knowledge. Verify source data. Document your methodology and report transparently. Identifying outliers is about uncovering truth and ensuring analytical accuracy. You can access a complete suite of statistical tools, including the IQR calculator, at MiniWebtool to support your analysis.